Just consider the table student device in this slide. All the rows in the table are uniquely identified by the SID. This is because each entry under the SID column has distinct values, which are S10, S20, S30 and S40. Clearly, there are no duplicate rows. That's why SID acts as a primary key column for this table named student device. This table holds two pieces of information, one for the student represented by the columns SID, SNAME, SCT and SState, and the other for the device represented by the columns DID, DNAME, DCost, DProfit and QTY. QTY here means quantity. However, if you consider the columns DID, DNAME, DCost, DProfit and QTY, you will notice that there are duplicate entries for these columns as represented by the entries with color red. Each colored entries holds the values D10 for DID, RAM for DNAME, 850 for DCost, 20 for DProfit and 1 for QTY. In such cases, we may encounter three types of problem. Those are insert anomaly, delete anomaly and update anomaly. Let's understand how it occurs. The first type of anomaly is the insert anomaly. An insert anomaly arises due to failure to place information about a new entry in a table. In the next slide, I will show with the help of an example. Just consider the table in this slide. If a new student, say Pranav's data, needs to be entered, it can be entered very easily into the table by simply putting a new distinct entry of S50 in the primary key column SID and then filling up the remaining entries for SNAME, SCT, SState for that student Pranav having SID as S50, as can be seen in the table. The device information has been kept null for the student called Pranav, as this student did not purchase any device. Now let's take another scenario. What would happen if a new device information such as D40 for DID, rubber for DNAME, 200 for DCost, 10 for DProfit and 2 for QTY has been entered, that is not purchased by any student? Then in that case it cannot be inserted because the primary key column SID cannot be null. So this is the case of an insert anomaly. As a result, every device information has to be associated with a particular student. So information about new devices cannot be entered unless it is purchased by a student. The second type of anomaly is the update anomaly. Update anomaly arises due to non-synchronization of data while updating certain columns in a table. That means some entries in a column might get updated whereas some entries may not. In the next slide, I will explain it with the help of an example. We have seen that update anomaly arises due to non-synchronization of data while updating certain columns in a table. That means due to non-synchronization of data, certain columns get updated and certain columns not. Now consider this table. Say you want to update the device named RAM having DID as D10 to paper using the following update statement. That is, update student device, set dname equal to paper where DID equal to D10 followed by semicolon. Now the question is, what will happen if it is correctly updated in two places but not updated in one place, which is shown by the following table. In this case, D10 refers to RAM as well as paper, which is clearly ambiguous, as two devices cannot be assigned for the same device ID, which in this case is DID having the value D10. This is known as non-synchronization in a table, which is the case of an update anomaly. The last type of anomaly is the delete anomaly. So what is a delete anomaly? A failure to remove information of an existing record from a table causes delete anomaly. In the next slide, I will explain it with the help of an example. Consider the table in this slide. Let's say the student Tushar is going to a place called New Jersey in America, and so he wants to delete his name from the table student device. In this case, pen drive is purchased only by Tushar, as can be seen in this table, and if his record is deleted, then all information related to the device pen drive will be lost. So this is the case of a delete anomaly. So what's the solution to overcome such type of anomalies? The simple answer is normalization, as using different normal forms such as the first normal form, second normal form, third normal form, and finally the Boyce code normal form, such type of anomalies can be easily eliminated. We are going to discuss about each of these normal forms and normalization in the next PowerPoint presentation.